Okay, let's talk about units. Like I said, in any measurement, there are two parts. One is the numerical part, the other is the units part. So, for example, if I just say, my baby walked 5, one can misunderstand. Did the baby walk 5 miles, 5 kilometers, 5 meters, 5 inches? What? So, having units is an important thing, and the units have to be standardized. What I mean by that is that all the units across the world have to mean the same thing. So, if we are saying that we are referring to, let's say, a foot, and that means 12 inches, that measurement, that distance between point A and point B to be should be exactly 12 inches, irrespective of where you're making the measurement. So we call this the System International Units, and there are some basic units and there are some derived units. The basic units come from the basic properties of mass, length, temperature, amount of substance, time, electric current, and luminous intensity. Of these, the first six are what are you're going to see on a regular basis in this course and general chemistry too as well. And so it's only apt to know the name of the unit and the abbreviation that we use for the same. So kilogram is the unit of mass. Realize the kilo, the K is small. Capital K is reserved for Kelvin. Meter is for length, that's small m. Amount of substance is measured in mole, mol. Time is second, which is S, not SEC, just S. Electric current in amperes, capital A, and luminous intensity in candela, CD. Now, there can be units that are derived from these basic units, and then we are just going to use the word derived units for that, and I'll discuss that in a little bit. Now, a lot of times it's possible that you might have just a very big number. Let's say you have, 5,000 grams. In order to say 5,000 grams each time, rather than saying that, we use the word kilogram. So, kilo is considered the prefix multiplier, which automatically means a factor of 1,000. Now realize kilo is a bigger unit as compared to the gram. So this is a table which has all the prefix multipliers that we would be using. Giga is for 10 to the power of 9, mega for 10 to the power of 6, kilo, like I said, for 10 to the power of 3, 10 to the power of 2 for hecto, 10 to the power of 1 deca, 10 to the negative 1 deci, 10 to the negative 2 centi, 10 to the negative 3 milli, 10 to the negative 6 micro, negative 9 is nano, negative 12 is pico, negative 15 is femto, so on and so forth. Just an FYI, the size of an atom is usually in the range of nano and angstrom, so 10 to the power of negative 9, negative 10, that range, and the size of the nucleus, that is in the range of 10 to the power of negative 15, so that's femto. The one that I have put an asterisk by, those are the important ones. Those you should know at the back of your hand. Now, in a test, I will give you conversion factors between systems. For example, I will tell you that an inch is 2.54 centimeters. But you should know that 1 centimeter means 10 to the power of negative 2 meters. So what centi means, what milli means, the prefix multipliers, you should know all of that. Okay, let's then talk about temperature conversions. What are the scales? How we go about it? Basically, there are 3 different scales that temperature could be measured in. One thing I would like to say is temperature measures the net heat content, but it's not the same as heat, as some people might think. Now, in the US, we use the Fahrenheit scale, and that means that water would freeze at 32 Fahrenheit and water would boil at 212 degree Fahrenheit. In terms of Celsius scale, that number happens to be 0 degrees Celsius corresponding to the 32, 100 degrees Celsius corresponding to the 212. So if you realize 212 minus 32, that's 180 Fahrenheit. That is equivalent to 100 minus 0, which is 100 units. So realize that the size of each degree is, so let's write that somewhere, 180 Fahrenheit is equal to 100 degrees Celsius. And so that means that 1 Fahrenheit is going to be, the size of each degree Fahrenheit is going to be equal to 100 C divided by 180, which means 5 divided by 9 times C. So realize that the size of each degree is 5 over 9 times C. And of course there is a conversion factor because the 0 marks 32. You need to subtract 32 from here, and I'll talk about that relationship in a little bit. But there is a third scale that I wanted to introduce right now, which is the Kelvin scale, which is more of the scientific scale. And there too, the lowest temperature at which water freezes is 273 Kelvin, and the temperature at which water boils is 373 Kelvin. So if you think about it, the size of each degree Celsius and each degree Kelvin is exactly the same, because the difference between the two processes is 100 degrees Celsius. So the only difference between the Kelvin scale and the Celsius scale is that the Kelvin starts at 273. So one can say that any given point of time, it would never be a negative number. And that is the whole concept of absolute zero. Absolute zero is a temperature at which we expect that all molecular motion will come to a complete stop. But we haven't been able to achieve that experimentally. And even though we expect, theoretically, we expect that it does exist, but we actually have never been able to achieve a temperature as low as absolute zero. But since the basic difference between Kelvin and Celsius is the factor of 273, you can easily convert Celsius into Kelvin by simply adding 273 to the Celsius factor, and that will give you the temperature in Kelvin. Likewise, like I was saying, since Fahrenheit and Celsius, they are a little bit different than each other. The size of each Fahrenheit is also going to be different, and we learned a little bit about that in the last slide. If you have your Fahrenheit degree, the relationship is that 1 degree Celsius is equal to F over 9, 5 over 9 F minus 32. So that's what I was talking about when I told you that we will need to subtract the 32 because 0 means 32 Fahrenheit in the Fahrenheit scale. Alright, the question is, to carry out the indicated temperature conversions, you're supposed to convert negative 78 degrees Celsius into Kelvin. So like I said, Kelvin is equal to degrees Celsius plus 273. For the sake of argument, I'm not including the 0.15. So all you have to do here is to plug in the value of C, and that is given as negative 78. So this is going to be equal to negative 78 plus 273, and that will come out to be 195 Kelvin. If you wanted to go from Celsius to Fahrenheit, we had a relationship that Celsius is equal to 5 over 9 F minus 32. So we are going to simply plug in the value of Celsius as 158 and solve for F. So you're going to say 5 over 9. That wasn't typed correctly. So you will get 158 times 9 divided by 5 is equal to f minus 32. And then simply solve it for f. And I'm going to plug in the numbers on my calculator, and so should you. Plus 32. And I'm getting 316.4 Fahrenheit as my final answer. Realize one of these, it's going from Fahrenheit to Kelvin. How do we go about it? Please realize that that's a double derivatization. You will first need to convert the degree Fahrenheit into degree Celsius, and then convert the degree Celsius into Kelvin. So let's first do that. C is equal to F by 9 Fahrenheit minus 32, which is F, I'm sorry, I'm just keep saying F, it's 5 by 9. 98.6 is my Fahrenheit minus 32, and I'm just showing you the steps so you can follow along as you're solving it for yourself. And I'm getting a value exactly equal to 37. So now when you want to convert that into Kelvin, you would simply add 273 to 37, and so that would give you 310 as your final answer. Plus 273. Yeah. Now, as far as density goes, which is a intrinsic property given by mass over volume, and realize in order to determine the units for that, you can simply use the basic units, mass and volume, as length times length times length. So the density units become grams divided by centimeter cube. I've discussed that in good detail in a screencast, so please watch that. But I just want to take some time to go over unit conversion. So for example, if you want to convert over here, I'm showing 2.5 kilograms of mangoes into pounds. You need what is called as a conversion factor, and that conversion factor, again, if it is between various, like two different system of units, then I'm going to provide you that. Otherwise, of course, prefix multiplier you have to know. So here I'm giving you that 1 kilogram is 2.205 pounds. The way you work it is you write down the quantity that is given to you. So you have been given 2.50 kilograms. Notice I included the 0 because I want to keep the significant figures intact. And then you're given the conversion factor. You should write it in a manner such that what you need, that should be the numerator, and what you want to get rid of, what you want to convert from, that is going to be given as the denominator. So I'm just going to say divided by 1.00 kilogram. And that comes out to be 6.00 pounds, because the kilogram and the kilogram will cancel off. You are basically multiplying 2.50 times 2.205, and that gives you your 6 pounds as the final answer. So realize whenever you're using the dimensional analysis method, and you will be using it for a variety of conversions in subsequent chapters as well, what you want is the equivalent quantity. That is what you want to put as the numerator, and what you want to get rid of, that is what one you keep is as the denominator. And of course you begin with the original quantity, and the number that you get is the final answer that would be for that particular conversion. So that finishes chapter 1, and I'll be putting more videos and screencasts for subsequent chapters. All right, see you in class.